All right, we're going to talk about solving problems with trigonometry and your applications. We're not going to talk about every application, but we are going to talk about some of them that involve trig. So we show you a couple different scenarios that we've talked about before, and I can't believe I just did that, and I need to do this. Line of sight. We've talked about angle of elevation, how it's measured from the horizontal upward. That's how we measure everything that's called angle of elevation. So always from the horizontal upward. Versus something called angle of depression, which is measured from the horizontal down. I get a lot of students who think, we're flying an airplane here. I'll try to draw an airplane in the sky. I'm sure it'll be horrible. Yep, okay. So, and we're going to make a landing on a runway. It looks more like a dead body, but oh well. So, we're going to make a landing on a runway, and we say the angle of depression. Well, so what I'm hoping that the child does is draws a triangle like this, with the airport being down here, and, measures the angle of depression. But what I get a lot of kids doing is this. They draw a triangle like this, and they think that this is the angle of depression. Well, guess what? They just messed up. That gives them the wrong the wrong angle, and so they end up with, they do not find the altitude or the horizontal distance, whatever I'm asking for. So make sure you don't do that. That's a fatal mistake right there. Don't do that part. Okay. Using angle of depression. So if we were talking about the angle of depression from the top of a lighthouse to the buoy on the water, and it says it's 30 degrees, so and the distance, the height of the lighthouse is 130 feet. Well, sorry for yawning. I probably wouldn't draw the triangle like they did. I probably would draw it like this. It does not matter. You learned in geometry that either one is going to be fine. And so it's up to you what you want. But you need to pick the correct trig function. So sine, cosine, tangent. It looks like we have the opposite side and we're looking for the adjacent side. So that sounds like a job for tangent. Tangent 30 degrees equals opposite over adjacent. Of course, anything can be divided by 1, and now we're talking about a proportion. And so let me grab my calculator here in a second. So we're going to make sure our calculator's set in the right mode. Of course, it's not, so we're going to switch it over to degree mode. That would be a crucial mistake. And we got 130 times 1 divided by tangent 30. And so we end up with 225 point. And that is the only drawback about doing it this way. 0.2. Okay. So that's your x value. Just keep in mind you're cross multiplying now, so that you understand that you're multiplying by those two and dividing by that one. That's how we end up with this 130 over tangent 30. Just to kind of further expand on that idea of angle of elevation and depression. So angle 4 is an angle of elevation from the boat up to the person, just like from the person to the airplane is an angle of elevation. So angle of elevation, we're talking angles 2 and 4. Your angle of depression is from the airplane down to the person and from the person down to the boat. So angle of depression here is 1 and 3. Now, as you can see, 1 and 2 are exactly the same because of alternate interior angles like you learned about in geometry, just like 3 and 4 are exactly the same because of that whole same alternate interior angle. Sorry, I didn't get enough sleep. I apologize. I don't mean to yawn because you guys hate it when I do that in videos. Okay, so now we're talking about a car's traveling along, and at this location right here, it's the angle of elevation to the top of the building is 22 degrees. They say angle of depression because evidently the person that's making the observation is this guy up here on the top of the building. Now, if the building's 100 feet, according to my drawing, he's, about 30 feet tall. But the angle of depression is 22 degrees, and then when the car gets a little bit farther, he measures again, and it's 46 degrees. So using that whole alternate interior angle strategy, we come up with these situations right here, or these right triangles. So I want you to focus on is the big one, and then inside of that big one is another one, right? And this one's 22, and this one's 46. Of course, the height of the building, 100 feet, that's not changing on either one of the triangles. And then this is D, and this is X plus D. Well, the only way we're going to find X is if we find D first. So, we're going to have to start with the smaller right triangle. And opposite, we want the adjacent, so that's tangent. So tangent 46 equals opposite over adjacent. So we're in that same situation we were before, cross multiplying, where we're saying 100 times 1 divided by tangent 46. It's just cross multiplying, folks. I know I kind of sped it up. And then we hit the calculator and we let it do the magic. We've got 100, come on, turn on, clear, 100 divided by tangent 46, 96.6, 96.6. So D is equal to 96.6. So now we can go to the other triangle and we can say, all right, so that means tangent 22 equals opposite, which is 100, right, over X plus 96.6, since we know what D is. Once again, cross multiplication, right? So 100 times 1 divided by tangent 22 equals X plus 96.6. And so now we can come over to our handy dandy calculator and start typing this out. 100 divided by tan 22. Find that number. What did I do wrong? Oh, I multiplied. I'm like, that does not seem right. 100 divided by tan 22. One of the greatest things I think you could ever learn in a math class is how to estimate so that you can find your mistakes. And that's true for any math class, including this one. So if I subtract the 96.6, I find out that we have 150.9. So X is 150.9 feet. All right, so we got the U.S. Coast Guard example here using the bearing scale. Let me refresh your memory on the bearing scale. 0, 90, 180. It goes in a clockwise fashion, 270. So you can see that the A is the Port Cleveland. That's what they're calling letter A. And the boat leaves at a bearing of 53 degrees. Well, remember, 0 degrees is north. So that's why they've got this 53 degrees. And so the boat travels to point B. That's the direction it's traveling, to point B. But when it gets to that location, it changes its bearing to 143. Well, remember, it's still 0 degrees at the top, so measuring to 143. Now, if you take 143 and you subtract 53, what you find out is that's 90 degrees. Okay, so it's very, very convenient. And, you know, why am I subtracting? Well, if you extended that out, you could realize that that angle's 90, which means the one inside the triangle has to be 90. So we're talking about basically a right angle, and we want to figure out, so if this boat was traveling for 2 hours at 35 knots, then we could say that it traveled 70 nautical miles. Now, and then on the other course, a bearing 143, it traveled 3 hours at the same speed, so that's 105 nautical miles. Doesn't matter, you know, whether it's nautical miles or statute miles. We're not converting either. We're just going to keep everything in the same unit of measurement. So, the question is, we really need to know this angle from here to here. So, if we know theta, so the bearing that we're really trying to find, or one of the parts that we're trying to find, is the 53 plus theta. We have to figure out what theta is inside the triangle. Otherwise, we won't know what the final bearing was when they landed over here at point C. We also want to find the length of the hypotenuse. Well, that's not too terribly difficult, right? We could do that. 70 squared plus 105 squared. And of course you take the square root. Not. $126.2. Okay, now to find the bearing, we want to, or the theta, we've got opposite and adjacent, so we want tangent theta equals 105 over 70. So how do we get rid of theta? Ah, yes, the good old tangent inverse of 105. Anytime you want to find that, get rid of that tangent, you've got to invert the tangent. Same thing with the other trig functions. Okay. Now you could do this all at once. I don't know why I'm doing it this way. Tangent inverse of the answer, 56.3 degrees. Theta equals 56.3 degrees, which means that the bearing would be 53, so plus 53 would be 109.3, because I'm just adding the 53 and the 56.3 together. Okay, finding the height above ground. So we have a large helium-filled penguin is attached or moored at the beginning of a parade route, waiting, I guess stuck, sitting there, at the beginning of a parade route, waiting to the start of the parade. Two cables attached to the underside of the penguin make angles 48 and 40 with the ground, and are in the same plane as the perpendicular line from the penguin to the ground. That's kind of important, okay? So they throw that in there. If the cables are attached to the ground 10 feet from each other, how high? So this is the situation we're dealing with the penguin, the balloon, and the distance 10 feet is where the cables are attached to the ground away from each other. And the angles of elevation are 48 and 40. Okay, so we're going to look at this as two separate triangles, just like we did the last question. We got the bigger one, we got the smaller one, and I'm gonna try my best to make them look a little bit different, but 48x h, 40, 10 plus x, and h. Now, you'll notice in this particular example that there are two variables. That's not exactly a nicer scenario. So when we set up, tangent 40 equals h over 10 plus x, and tangent 48 equals h over x, opposite over adjacent, you're probably looking at me going, well, what am I going to do with that? I think it's easier if we solve these equations for x, and then do some substitution here. I think it would be easier to solve for h. Yeah, that would be better. Let's solve for h. So if I solve for h in the first one, lock it in. I would get 10 plus x times tangent 40. And on the other one, I would get h equals, all I'm doing is cross multiplying, so tangent x times tangent 48. Okay, now if I don't simplify what those tangents are, you're going to get really mad at me, because it'll look very ugly, because you'll be seeing a lot of tangents everywhere. So what I want you to realize is that tangent 40 is a number, and tangent 48 is a number. In fact, I can come over on my calculator and show it to you. Tangent 40. Now, I didn't say it was a nice number. Come on. Now, we'll take it to the 10,000ths place. We'll say 0.8391. Okay? We'll call that 0.8391. And what we're going to do is we're going to distribute it to both of those. It'll look a lot nicer if I do it this way versus if I do it the other way. Tangent 48. 1.1106. 1.1106. Okay, so of course I'm going to set these two things equal to each other. It's substitution. Okay, so I've got my 0.8391 times 10 plus x on one side, and I've got my 1.1106x on the other side. And so now I'm going to distribute. That's 8.391 plus 0.8391x equals 1.1106x. And of course I'm going to subtract that to the other side. Let's see. 1.11, oops, come on. 1.1106 minus 0.8391 equals 0.2715. 0.2715. So we have 8.391 equals, what was it again? 0.2715. 0.2715x. Okay, so obviously we're just going to divide by that 0.2715. 8. That's not an 8. 8.3. No. Divided by 0.2715. Should have just used answer. 30.9. So x is equal to 30.9. Well, so now I can come down here and I can finish the question, or if you would rather use that example there, that's fine too. H equals 30.9 times tangent 48. Okay, so let me type that out on a calculator here. We got 30.9 tangent 48. 34.3. H equals 34.3. So that's how high the penguin was off the ground. Trust me, it looks a lot better if you just go ahead and distribute those decimals in there than if you start writing tangent 40, tangent 48 everywhere. So that this next example will be for Monday. So that's all you need to worry about for this weekend. Take those notes, and we'll be ready to start the Ferris wheel problem on Monday. And sorry I didn't get another song for you because I have been way too busy trying to get ready for this trip.